We're almost at 100.
Is that true?
I'm Matt. I'm a .NET developer.
I'm Richard, also a .NET developer.
Surprise.
John, also.
Well, first things first.
Oh yeah, sponsors. Here are our lovely sponsors. Fruition are an excellent recruitment agent who are in
Stick
here
your hands
somewhere.
up. Fran is at the back, keeping warm.
Yay!
If you need a job, go and speak to Fran. They're lovely people.
So we also have Tronic, an excellent e-commerce place.
Conflux.
They make educational
Yeah.
books.
Yeah, it's Matthew Skelton. He's a very capable consultant.
Stackify, excellent logging for your site.
Love these guys, Stackify.
What's PostShop?
PostShop is not sponsoring us anymore.
Oh. Ignore PostShop.
Nice of you to tell me.
Sorry.
Oh, you can take the feature line.
Are we rolling, by the way? Sorry, we like.
We are now.
Yeah,
Okay,
okay.
fine.
All right. Okay.
Live stream. Have
Anyway.
you started without telling us?
Thanks for coming. If this is your first time, welcome to Lead
This
Sharp.
is your 98th time. Well done.
Oh, I thought of a catchphrase that we might, because we've got Leeds Digital Festival on.
We need a
And
catchphrase.
yeah. I thought, because we're broadcasting this and all that, I was thinking, what was it again?
Nice to see you.
No. Who's sharp? And then you go, Lead Sharp. All right? So we do that.
I think we should put it to a vote whether it's cool or
No,
not.
come on.
It's not going to be cool.
Was
either.
nice to see you, ever cool.
Well, yeah.
Who's sharp? Yes! All right, so kicking off with the news section, we've got various sections. Right, so we've got quite a bit of language news. TypeScript 3.4 release candidate was released this month. The new version includes incremental compilation, which allows you to save information about a project from its last compilation. It will then use that information to determine the most efficient way to type check and emit changes to the project. Presumably,
That's a good thing.
makes it quicker to compile. It's also got added new syntax for read-only arrays. Anyone excited about that?
Anyone, who's using TypeScript?
TypeScript? Quite a few hands. Yeah. Is TypeScript even relevant anymore? I mean, it's
Yeah.
like,
Yeah, definitely.
yeah.
Strong typing at design time. Very
yeah.
nice.
Well, I love it. I
You
love
don't get
it.
that
It's
with
just-
Java.
Cool. By the way, there's a noticeable move towards vanilla JS, isn't there? Really? Who's using jQuery, or who has to use jQuery in their project still? And who's using vanilla?
I'm vanilla in my own stuff.
Are you
and
vanilla?
jQuerying at work.
So it's sort of like a badge of honor, really, isn't it? And
Well, vanilla JS is all well until you need like a date picker and the libraries in jQuery, so you need jQuery to fit into that.
yeah.
And then you need this other functionality in the UI. So
You definitely get a lot of speed out of
Well,
it.
yeah, I have to admit, I was all like, all right, okay, I don't need jQuery anymore, and then I came to Ajax. Okay, great.
Oh, that's
I
not
was
that
like,
bad.
really? Well, I just couldn't remember anymore. It's just that's the problem, isn't it? That,
It's impossible to program without Google now.
yeah, but there's plenty. Most of the big frameworks like Vue.js, for example, and all that, they all have a non jQuery.
Well, jQuery is
version.
quite often against their model of working as well. It doesn't fit
Yeah.
in as well.
Yeah. Anyway, I'm drifting.
Yeah, how much news we got?
We've got quite a bit of news. Okay, so Apple, this is not .NET, but we need to know about other languages as well. So Apple releases Swift 5. Anyone use Swift?
I've not learned Swift from yet.
someone does.
Let's turn this off. So the official release was yesterday, and that was 2 days ago, so 3 days ago. With the library features being implemented into main Swift, they no longer have to be bundled into compile applications, resulting in small and fast apps. So there's a theme with all these packages, and that leads that is sits nicely with the vanilla JS as well. With more and more people, more and more users, traffic coming from mobile only, performance obviously is a big one, and anything that brings down page load time, for example, or you know, sort of response time is there's a definite focus on performance,
Smaller.
isn't it? Because of the shift to mobile. Right. So I've got because we're doing IoT, I thought I'd include this. Cloudera's new IoT solution. Anyone heard of Cloudera? Cloudera. Yeah. Okay. So they've announced 2 new solutions to make it easier to get data from IoT devices. Cloudera, is it Cloudera? Flow management (CFM) is a highly scalable data ingestion and management solution, and Cloudera Edge Management (CEM) is an edge management solution for IoT and streaming use cases. The key challenges with IoT are around edge management, like the inability to control and manage edge agents, difficulty in collecting real-time data from edge devices directly, and most importantly, the trouble with updating specific set of agents with edge applications. So they've obviously addressed that. Good news. Java 12 is now available, major release.
Have they got functional programming yet?
I don't know, but there were 1,919 Jira issues that were marked as being fixed in Java 12, and apparently Java 13 is also on.
The unlucky Java.
It's been released in September, so I think they've sort of done the same as Firefox and just moved to major versions, and you know they're rolling the major versions a bit more. This was quite interesting. Python overtakes JavaScript as the most questions language on Stack Overflow.
Oh.
That's so the most people are confused about Python over JavaScript.
Yeah, exactly. It doesn't mean that Python is more popular, but
Still are confused.
but okay, there you go. Have I got anything I had? Oh yeah, okay. Here we go. Either Python is fast becoming the most popular programming language, or Python just has a bigger proportion of new coders compared to other languages, which is probably the case, right?
Yeah, new or confused, and or confused.
Okay. So that's the news
So
section.
we had DDD North this month.
Oh, yeah.
Loads of great speakers. It was held in Hull this year, Hull University. It's a great conference. So about Hull University is they definitely don't have any students there because it's the cleanest university I've ever been in. Really nice venue. Lots of good people to talk to. Finally tracked Rob down. I've been trying to get Rob over Twitter for many months, and he ignored me. But when you go face to face with him,
You pounced on it.
yeah, I'm happy. So we've got Rob here tonight.
All right. Well, moving on to our next section, which is Kaizen Bits. Kaizen Bits is, if you don't know, is basically anything that makes you a better developer. So you're quickly becoming the Kaizen Bits man. If someone has to do a Kaizen Bits.
Someone else has to do next month.
No, I've got some Kaizen Bits, but it's that you always want to do it, don't you?
Well, then I'll run out of ideas, or I'll be on holiday or something.
There you go. So it could be a book, it could be a resharper, shortcut. But what is it today? It's IoT related.
It is IoT related indeed.
There you go. Off you go.
Right, it's either IoT related or it's in pursuit of my quest for world domination. So this is the Netduino 3. So this is an IoT board. So what you've got here is a central processing unit. You've got onboard Wi-Fi, but there's also an Ethernet version. You've got power sockets. You can put in a micro SD card, onboard switch, an LED, and some standard peripheral interfaces. So these things are really easy to interface with. If you don't like electronics but want to do electronics, what you do is you buy a shield, what's called a shield, and you stack it on top, and that is all your wiring that's done. So
Anyone got a Netduino?
or an Arduino.
In a drawer.
Or a Gadgeteer?
So Arduinos are more popular, but you can use all the Arduino shields with a Netduino. The Netduino has the advantages that you debug with Visual Studio and you write in C#. So the specs, you've got general purpose I/O, so that's on or off, so you can turn LEDs and lasers and that kind of thing on or off, and you can do something like pulse wave modulation, so control speed up and down kind of digital signal. And then you've got a couple of interfaces to serial interfaces. These can control screens and Bluetooth and that kind of thing. The NetDuino either has Ethernet or Wi-Fi as standard. They're dropping the board with no network access. Micro SD slot. It all runs in the .NET Micro Framework 4.2, so there'll be a sort of standard interface programming model that you should be fairly familiar with, and the sort of NetDuino bits, I'll give you a little demo of those. And it's almost £50, the Wi-Fi board from Mouser Electronics, if you're interested in buying one. So as I say, the standard electronic interfacing model is these idea of shields. So here I've built one. So this is the NetDuino layer, and then you sort of stack multiple shields. Sorry, for the benefit of the camera, you stack multiple shields. So you can put as many of these shields on top, and you can create sort of Leaning Tower of Pisa functionality and capability on top of that. So here you've got an MP3 player and a memory card expansion on top of that, so you can play some music through it. This is a TFT touchscreen, so that acts like a normal screen. Again, you've got the standard interface sort of drops on top of all the boards. GPS, motor drivers, as in my example, for my robots to take over the world. You can drive relays if you want to drive something more than 240 volts, so that kind of thing. You can communicate with the outside world using GPRS. You've got camera on board. If you want to go pure electronics, you've got these kind of prototype boards, these pin boards. You drop components, LEDs, wires, whatever you want on top of it. Smoke detectors, RFID, and then you can go the whole hog, which is like, I just want a robot and program in C#. So that is Arduino board with the motors and a little switch interface already programmed. So in order to program it, you need Visual Studio 2015. I don't know why it's not 2017 compatible. You need a NetDuino SDK and the .NET Micro Framework add-in. Once you've got all that and a USB cable, you just plug it into your computer. It goes, oh, okay, there's a device I can talk to, and then you can program. And more beautifully, you can debug. So you can see the peripherals working on the board, and you can step through the code in Visual Studio as it's executing on the board. So a really fantastic developer experience. So if you can see at the back, so this is how I set up my LED. So I just set up an output port and then refer it to a pin. So they've all got a set of standard pins that you can interface with. And then there's set up an input port, which is the button, and then again give it a pin number. And then here I turn the LED off, and then I put it through a loop, and then write the status of the onboard switch to the LED. So basically, as you press the button, the light shows up on it. It's a very, very simple program, but that's how you set it up. Okay, so this is my killer car. Obviously, as a good developer, I'm on a quest for world domination. So what you have here is a NetDuino board, and this is a motor driver shield all wired up. And then I've got a prototyping board, and I just use the two LEDs on top. And of course, I had to fit a laser on the front. So we'll just give this a go.
Oh, this works.
Matt, if you don't mind, I'm just going to use you as a guinea pig. Just tell me when you feel pain. Right, so when I press the button, it's hooked up to an interrupt. And it will chug along for 10 seconds, flashing its lights, and then it will kill Matt.
Don't give this to ISIS.
There you go.
Oh.
There you go. So that is about half an hour's work, including the programming. Stack, programming, Matt's dead. So what does the code look like? So I've got onboard LED, onboard button, and then on the onboard button I'm setting up as an interrupt, so I just loop in some code into that says when I press the button, go into this code, and it does some other stuff. set up the motor shield, so I've got a pulse wave modulation input here that controls the speed, so I can go slow or fast, and then I set up whether it's going forward or back on each motor, and then I've got some lights, the left LED and the right LED that you saw flashing there, and the laser. So the interrupt just handles the button click, so I change a variable when a button's depressed. And then when the button's depressed, I start the left motor and the right motor, and then flash the LEDs. So if you want to get started, there's a fantastic website, Wilderness Labs. They've got all the materials, they produce these things. So there's a get starting, how to set up, really very simple, how to get going with it, and then how to program pulse wave modulation with code examples, so it makes it very, very easy for you. Great development experience, as I mentioned. There's something called Meadow coming, which they've crowdfunded about a month ago, so that's the .NET standard version of an Arduino. So it's quite exciting, and that's my Kaizen bits.
Cool. Thank you very much. Moving on to our next section, which is design pattern recognition. Where's the theme music? So the whole point of this section is to just go over design patterns, because we can't go over design patterns enough. I realised from last time that we were catering for all sorts of skill sets. There might be some beginners here or not. So I found this presentation that we did ages ago, and I called it Design Patterns Complete Guide in 60 Seconds. Well, I thought I'd go through this first. Go! So the whole point of design patterns is, I like that design pattern, steaming pile of crap pattern, is that it's templates for solving common problems. I'm not telling anything new. It's not code snippets that you can cut and paste into your application, but rather a starting point or a template, and it defines how code relates to each other rather than giving you sort of concrete solutions, shall we say. It's as the name implies, it's used for application design, and it's tried and tested. I don't know, is there like is there a group of people that sort of give like a sign of approval to design patterns? I don't know how it works. If you find a new design pattern, who do you go to?
If people like it, it gets popular, I guess.
I don't know, yeah. But anyway, they're split into different categories, and that's apparently called a pattern language. How are we doing with the 60 seconds? It all apparently stems from this guy from architecture, who's called Christopher Alexander in 1977, and then Ken Beck and Ward Cunningham, who we all know, got onto it, and then the famous Gang of Four released the book with 23 design patterns, of which one of them we'll be talking about today, yeah, that's what it's called. Design patterns, elements of reasonable. I'm sure all of us have read this book. So the whole point of design patterns is that you don't reinvent the wheel, and it's important because it's like developers.
We like to reinvent.
We do, don't we? We think if you think about the stereotypical developer introvert, locked in a room, thinking that you're, like, I'm a genius. I know you do it that way, but my way is much better. But that's not good in a professional developer scenario. The whole point is stop reinventing the wheel, and talk the same language. That's also important, especially when you hand over code. You don't want to spend days, reading through the code and understanding the code. So if you recognize common design patterns, that helps productivity, which cuts down cost and development time, and avoids technical debt, which we all love, don't we? Because it means more money for us. and it improves maintainability and readability, which it's close to my art because we've all seen the code base where there's variables named t and x and it's got various constructs. So here are the categories of design patterns. Am I running out 60 seconds?
Definitely.
All right. I don't know where the communication. The observer pattern. Maybe Rob will be able to help me out. The observer pattern is a communication pattern.
Newspapers.
There you go. I don't know why I'm going into creational patterns. Oh yeah, okay. So here, an example of creational patterns. Maybe we'll have the observer pattern here. Structural, behavioral patterns. We don't have the observer pattern.
This was never going to be 60 seconds.
Model view, enterprise design patterns, model view, gateway pattern. That's getting closer, isn't it? Domain-driven design patterns, reference objects, value objects, aggregates, repositories, and that's it. There you go. Was that 60 seconds?
Exactly 60
anyway,
seconds.
I thought I'd give this intro every time to this section, just in case we have junior developers coming and I don't want them to feel intimidated about talking about different design patterns. So today I thought we'd talk about the observer pattern because we're talking about IoT and it's a communication pattern. It's a very chatty pattern. So what is it? It's one of the original Gang of Four design patterns, 23 of them. It defines a loosely coupled one-to-many dependency. You have a subject, and you have and the subject has a list of observers, and the state is communicated through the subject to the observers. And you can register observers, and it's closely related to the pub sub pattern. The only difference to the pub sub pattern is that you don't know who the observers are with the pub sub pattern. So you usually have a third party element like service bus in there, which you just publish to, and that has the advantage of being able to filter and just publish it to whoever's listening. So here's the UML of it. So like I said, you have the subject, which you can attach observers to the so you hold a reference of each observer, and then you can call the notify method on the observer, and I've got a little bit of code if you've got that, tailored towards IoT.
Off my cursor, you can have your code.
Yeah. I don't know how we're doing. So we've got a fridge, which is if you could just go into fridge. This is the concrete subject. Yeah, concrete subject, and the subject is the appliance. You go on now. So as you can see, the appliance holds a list of suppliers, and if you go back to program, you can add or you can connect. I thought I'd call it connect since we're in the IoT space now. So you've got an IoT connected fridge, and you will connect Sainsbury's, Asda and Ocado to it, and every time you drink milk, you tell it the new quantity of milk that you've got, and then all the supermarkets who've observing the subject, which is our fridge, Matt's fridge, get notified and then can send you lots of spam about milk. Yeah. Can you F5 it?
Hopefully that's the key combination for this computer.
There you go. Sainsbury's, Ocado, and Asda know about my fridge, my milk consumption. There you go. That's the observer pattern. Thank you very much. All right. So we're going to take a short break now to get set up for the main speaker, who John is kindly introducing.
You want me to know?
Yes, please.
Okay, so I've been trying to get a speaker on IoT for a number of months. I've been trying to harass Rob via Twitter, but he was very good at ignoring me. But then I managed to bump into him at DDD North. And he said, oh, well, actually, yeah, oh, you're that guy. Yeah, okay, I'll come. Rob is former professor at Hull University, MVP, has written a book on C# and Python, most recently. Some great reviews on Amazon for those books. But basically, when I retire, and you are semi-retired, aren't you, Rob? Semi-retired. I want to be Rob because this man has all the toys. He has the 3D printer, he has the robots, he has really cool community projects that he does with his software engineering. And I'd much prefer to spend my time working on really cool projects than doing what I do as a day job. But I've still got a mortgage to pay. So he's a fantastic speaker. He sings, he dances, he rhymes, he tells jokes and poems. So he will be a great speaker.
He's doing all of those things again.
All right.
Maybe not.
Maybe not all of them.
Thank you. We'll see you about 5 minutes, and we'll get set up.
Inviting me. I'm not sure whether the Twitter thing's interesting, but yeah, okay. Right, so my name's Rob Miles. I'm going to be talking to you about air quality. Let's just see if this works. Oh, look at that. A little bit. Lora Azure functions. That's what you're going to get. Take about an hour, seem much longer. There will be jokes. I was reading in the paper, there's a lot of stuff about self-drive cars coming out. I hired a self-drive van over the weekend. It was terribly dangerous. That didn't work at all. Moving on. Okay. Okay, so I spent 30 odd years teaching computer science at university. I was in charge of twisting minds and crushing dreams. I got very good at both of those. I blog at robmiles.com, Twitter at robmiles. I write books. This is my begin to go with. These are the gratuitous plugs. Yeah, but that's begin to go with C#. That's look at that 5-star. Thanks very much, Mum. 1, 3. Awesome. You've got to go with that one. I did a Python book too. The whole family weighed in. Quite frankly, they weren't quite as generous, which I could do with a bit more support on that one. But yeah, they're out there. You can rush out and buy them, or just buy them down on Amazon. I don't really mind either way. What I want to do though is talk about air quality. This is only really interesting if you happen to be someone who breathes. So that's kind of a good starting point. If you go online and you start looking into this, as we have done, you find that the Met Office has all these ideas about, it has climate prediction models, and it also will tell you about the air quality in your region. And the scary thing for me is that, yes, it does, but these readings aren't real. There are 3 or 4 sensors around the country, and then maybe more than that, but not that many, and then they sort of big software model, feed it in, do lots of sums and predict what the quality will be like in your area. There are no or very few local measurements. In the whole of East Yorkshire, East Riding for example, there aren't any sensors at all. So you get numbers because you can do it with a model, you can interpolate and all sorts, but what they mean is with no idea. And so what we thought we'd do in Hull, because I'm a part of a group called Connected Humber, which is actually involved in making stuff, we thought what we'd do is get into something like air quality to give us a project to do things. So have a look at this, it's quite kind of fun. There's no real numbers. If next door fires up their wood burning stove, then the area around the house, that house will get quite bad air quality for a while, maybe. We don't know. We haven't got sensors that tell us this. We've got all this stuff about people picking up their kids from school using Chelsea tractors. Is that causing a problem? We don't know. Does the air pollution that we get in this country come from us, or does it blow in on the wind? We just don't know. So we thought, well, let's have a go at finding out, because it's kind of like a fun thing to do. And so you go online and you find this. You find a table a bit like this. And this talks about air quality indices, where green is okay and purple is not great. And then in between you've got these pollutants. And the one we're really interested in is this guy, which is the parts micrograms per cubic meter of 2.5 micron particles in the air. And there are a bunch of numbers there in the various bands that indicate how bad this is. Now, we went for this because you can look at things like nitrogen oxide and other bits and pieces, but those sensors are really hard to use if you've not got lots of money. They're quite expensive to buy, and they require calibration. So we thought we'd buy some sensors and see what we can do with it. And we thought, if we do this, we can get some numbers, and we'll compare them with the real sensors in Hull, because there are some, and see how we get on. We're keen on these 2.5 micron particles because these have the annoying ability to go through your lungs into your blood and accumulate. So these are the ones you want to be careful of. These are the ones that will cause ongoing. And every week goes by, another air quality scare story. And so you have to be very mindful of the fact that this stuff, we don't know what it's doing. The human race has this amazing habit of performing experiments on itself to see what happens. And this is one of them. We're burning fuel, we're driving around in cars, we're making tiny particles in the air. We have no idea where it'll end, but possibly not well. So we thought we'd buy some sensors and see where we go. And so that's what we did. Because one of the things I'm really keen on is trying to use tech as an agent of change. One of the things we did, we went to see the local council in Hull City Council and talked to them. We said, we're thinking about measuring air quality. And they turned a very funny colour and sort of backed away towards the door because they thought, okay, what Rob's going to do is just going to go you're going to get some big numbers from something we've no idea about and then go nuts, and the press will go nuts and it'll be terrible for everybody. That's not what we're doing. We're making it very clear to everyone we're making numbers and we're trying to build provenance for these. And we don't see it as Hull City Council's problem if the air is bad in Hull. We see it as something which everyone has to think about doing something about. And so if it turns out that we put some sensors outside of school and we do find that things go downhill when people are there with their big cars, picking their kids up, then maybe they'll change what they do. We've had lots of quite nice nudging effects with things like doggy doos, doggy poo and shopping bags. People are now behaving better because they've been told this is bad. This is what you should do to make it better. So I'm very keen on doing this because if we can get more information out there, we can empower people to make choices about what they do and where they go to try and improve things. So I'm quite keen on this as a tech approach to improve the world. And the other thing about this is that it's a great way to learn how to do stuff. It's just making stuff is just awesome as a way of actually improving what you know and what you can do. We thought the hard part of our project will be getting the sensors to work and getting readings from them. That took an evening. The hard part is figuring out how to make an enclosure to go on a wall that won't get frazzled in the sun and freeze solid in the winter and get full of spiders' eggs, and how you can get the power to that through the wall or whatever and give this thing to a user and how they might be able to use it and make sense of it. That's the hard bit. So there's a whole deployment and support piece that we're having to get our heads around, and it's really hard. But at the end of it, we'll know how to do that. So when someone comes back and says, okay, I want to do things like footpath usage or perhaps water levels in becks and streams or whatever, we'll say, okay, now we know how to make sensors and deploy them and network them, just another area to go in. So that's kind of, we're very keen on this because we're having great fun. And I guess you can regard me, I guess, like a man in shed type person, but I've got a soldering iron and a few other bits and pieces as well. And so it keeps me out of trouble. But it's also a good thing to kind of build up skills in the area. If we can spread people's ability to make this stuff, that's really good. So that's why we're doing it and broadly what we're doing. So let's now do some tech. If you want to measure air quality, you can go out and buy one of these guys, and it has a freaking laser in it, which is awesome. Okay? What you have is a heater here, which heats the air going through this device. The air rises. We have a laser LED shining a very thin beam down here, and a lens system and a photodiode looking for twinkles, basically, and counting them. This guy counts twinkles. Basically, there's a signal going out of him that goes into a processor on the back, and that then gives you a reading which gives you an approximation of the number of particles of that size going up in the air through there. Now, this is not a very good sensor, but for £5, what do you expect? It's So here's a question. How many folk here have heard of AliExpress? Ooh. I'd show you it, but I can't afford to. Because if I go on there, I'll spend about 15, 20 quid every freaking time. It comes from China. It's awesome. It's all post-free. I bought an ESP this morning, and it cost me, I think it was about 5 quid shipped from China. The prices are just insane. And it's very addictive, and you can get lots of good stuff. But these guys, I got 4 for 16 quid, and I've been playing with them. And we have concluded that basically they're fairly rubbish. And the reason why they're rubbish is, well, am I surprised? They're rubbish because this airflow model doesn't work very well. If you have it in a static position, away from air currents, then maybe it'll work. But what you really want, one of these guys, this is the SDS 011, of course we've all heard of this. It's a classic of its time. £13.73, you get it for around 10 quid now. It comes with a PC USB adapter, so you can plug in your PC and get numbers straight out of it. And it has a fan. And it has a nozzle on the side, on the other side, just that there, which you can plug a pipe into. So you can actually suck air in through a pipe and then get the particle density from it. And this guy is fairly stable. We've actually been running 2 or 3 of these in the same physical location at the same time and comparing numbers. They're consistent within themselves, and they track the posh, proper readings quite handily as well. There are problems with them. They're sensitive to humidity, because when the air gets humid, the particles swell up, and that causes the readings to get distorted in various ways. But we're trying to figure out how that is and compensate. But again, this is all learning stuff. And if you go online and look, there's people doing this, and they're proper scientists with white coats and everything. And we're just playing around in sheds and getting stuff, and it's really interesting. We're starting to see things. And it's been quite fun. So I've got my sensor, yeah, let's have a look. Yeah, I've got some sensors and bits and pieces here. This is actually the prototype for one of my devices, and this is, that's a white cable, but that's not important. This is a smaller version of the same. This is a pan-product sensor, but we started messing around with these things, and we thought we'd build a device. So we did, and here we go. Right, so we've already seen one microcontroller, which is the Netduino. Let's have a look at a few more because they're fun. Really, I love these things. We have to have something which fetches the data. This thing drops out a serial stream of numbers, which are the information which you have to take and then do something with. So let's have a look at my favourite chip in all the world. Not quite, actually, there are different ones, but I do like them a lot. This is the Wemos D1 Mini. This guy here, it has an ESP8266 chip on it. Of course you all know this, of course. And the thing about it, I like it best, the most important numbers on this slide are £2.50 each, right? And the other one is Wi-Fi. This guy talks Wi-Fi. So you get one of these for £2.50, and you have now got a device you can hang off Windows IoT Hub to make a connected device. And it has one analog input and 2 digital PIO pins and whatnot. I mean, the Netduino's great, 50 quid, fantastic. This, you get 20 for that price. I mean, that's a whole denial of service in a box. Wonderful. And so, yeah, this guy, you program it in C using the Arduino SDK, and it's awesome. You should just buy a bunch of this. That's less than a pint of beer, for heaven's sake. And it's just crackers. That's what's on this board here. That's what's inside my robot there. Well, anyway, I've used it all over the place. I buy about 10 a month and then work my way through them. Because why would you not? At Christmas lights outside the house, one of these. I can upgrade the firmware in there over the air and change my light patterns. Just bang, just do it. It's awesome. Really great fun. So get one of those and play with it. You should so do this. If you've got more money, you're going to go to you can buy the ESP32 for about 5 on its own. I bought one of those this morning. If you buy the Heltec version, this guy here has an OLED screen and it talks Lora, which more towards the end. So this guy's a bit more power. It's a dual core processor that you can clock at 240 megahertz. It's just crazy. It's just absolutely mad. But you can get that. You get the chip itself for 5 quid on a board like this, 12 quid. Or you can go a bit further up. This guy's called the M5 Stack. No, this is big one. This is 25 quid. But you get an ESP32, you get a nice LCD panel, you get some buttons, you get a speaker, an SD card slot, you can play MP3s on it. That's a battery base. You can stack it with other things as well. And that's a nice finished product. That's quite cute. Core M5, each of those sides is 5 centimeters, so it's tiny. It's very cute. If you think in terms of your prototypes having to look like this, which they can do with the M5 stack, it actually looks quite nice. You could show the boss that and get him on board, and quite impressive because it's quite cute. So these are all quite sweet. If you've got lots of money, buy the Azure IoT DevKit. That's about 40. This is interesting for one very important reason. That chip down there, little hand on there, is marked security. The other ones, if I get hold of the chip, I can unpick it and I can pull out things like Wi-Fi credentials and access keys from the device. If you're clever, you can do that. This guy, no, because that guy there does encryption. So you can sign assemblies and things and put them in there, X500 type stuff, and you can make darn sure that if that falls into the wrong hands, which it might do, you can't get any keys out of it. One of the things you have to be very mindful of is security in the IoT world, because lots of things aren't. And you buy these mains controlling plugs from China, which have quite often got 8266s in them, and they're eminently hackable. Then again, if someone breaks into your house, they can get your Wi-Fi password from the back of your router, so I mean, it's not really that much of a problem. So yeah, these things are really quite sweet, and they integrate nicely with Iot Hub, of which more a little bit later. Is this all making sense? Is everyone happy? As a friend of mine started going out with a girl who's got X-ray eyes, but I've no idea what she sees in them. Now you are paying attention. Jolly good. Yeah, okay, so I like making hardware. It's really fun. You're programming in C++ with these devices. If you want to, you can use Visual Studio or Visual Studio Code, or a free thing called Arduino IDE, which is also quite sweet. And there's loads of libraries for devices and sensors, for stepper motors, servos, and you name it, all kinds of good stuff. So you should be playing with this. And if you've got kids, you really should be playing with this. Absolutely. So, okay, I wrote some firmware for the system, which I call Monitor, and you turn it on, and it pops up as an access point. There it is. So I can now configure that using my iPhone, and it push this thing will host a website, for Christ's sake. It's incredible. £2, and I've got a website running off it on my iPhone. So I configure it with my SSID like I would an Alexa, and after that I can then set it all up and get it going. I'll play with this later, we can talk to it and tell it to do things as well. And so that was the firmware that I made. This is my first proper sensor, and where is he? He's in the box down here. Yeah. This is the, where are you? Ah, yeah. This is my first proper sensor. This is the version 1. It has a picture of a flower, and it's actually got pulled off. That's really good. And if I fire him up, he'll go online and start. He's powered by the Heltec device, and you can use him to get readings and push them into Lora and all kinds of other places as well. So if I turn him on, he'll start giving us readings. There's one of those big shiny SDS sensors in the bottom. So if I do that, he wakes up, there you go. Tries to find some Wi-Fi, probably fails. No, he's trying. Good. No network's okay. He'll sit there, and now, let's have a, what's our body like? What do we like in here? Let's have a look. It says about 11 or 9 on the 2.5, so we're okay. We're going to live. It's all good. It's all good. Anything below 40 is okay, and it's at 9, so we're all right. Nobody sneeze. It's fine. It's fine. So that's my first one, and I'm making one with a GPS receiver, so it'll track where you are. That's that guy there, but it's not very good. You don't get much for £7, it turns out. I'll go with a better one. And so that works. That's fine. This is the one I've been looking at as well. It's my top hat, because everyone needs their clothes. This is my top hat, which I'll turn on. Now this guy, wake up. There you go. This guy, he wakes up. He finds my iPhone.
Rob, does that tell if you have bad breath?
Tells if other people have bad breath.
Oh.
Because the problem I've got with this is that I can't see the readings. And I can, is he going all right? He may have found the Wi-Fi, not sure. What I can do with him is, turns out that these things are very sensitive to this particular one. It's the noise. Yes, he doesn't. If I rub it, it's gone anyway. But if I rub some tissue paper on here, it goes absolutely nuts and goes red. After a while, he'll settle down and go back green. I'll leave him there, just chuntering along to himself. He'll go back and then go green and settle himself down. So yeah, he's basically an ESP, an 8266 with running my software and an ZPH, which will settle down. You can watch that now. It's much more fun than watching me. So there you go. That's the back of it. It's powered by Windows Phone.
Whoa.
Yeah.
There's a purpose for Windows.
If you want, I've got some Windows Phone stickers here if you want one. The Windows Phone sticker?
I love Windows Phone stickers.
Okay,
Join my Windows
okay,
Phone.
I'll get it right. Here, you have a sticker. There, anybody else? Another back. Pass that to them. And there you go. There's one. There's a couple. How do you and you two as well? Find those. Okay. But yeah, there you go. Changed your life. Yeah. So more on how it works a bit later, but you can make it's gone green now. It's a bit happier now. Yes, if I give it if I hit it with a tissue, it'll go red again. Now, the thing about tissues is they seem to give out these particles, which I think we're fine if we don't breathe in through these things. We'll be okay. Whatever. It's getting there. It's quite happy. There you go. It'll settle down. Hopefully, it's pushing guys into the cloud as well, which is more on a bit later. So we've got our things working. How many folk here have heard of MQTT? Oh, a couple. Oh, great. Oh, more. Lovely. That's good. You can put me right on a few things. The devices we're looking at have all got Wi-Fi, and so that's my first port of call for even my £2.50 WeMOS device. And you can make them into web servers. They can support web sockets. You can do all kinds of RESTful type funky things if you want to. And there's loads of things out there that you can do. So, but what you tend to end up using them for a lot in the modern way of doing things is MQTT, which stands for Message Queue Telemetry Transport. Very hard to say. Now, that observer pan stuff was awesome because it's kind of goes straight into what I'm talking about here, because MQTT is a bit of that publish subscribe thing, only made live, in that what you've got is basically a broker in the middle which will take things and then forward them on somewhere else. That's exactly what MQTT does. And so, yeah, apparently it's used by Facebook for lots of things as well. It's not it's quite lightweight. It's very, very fun to use. It's a great way of making things work. You have a broker in the middle. Your sensor node publishes to a known topic on the broker, and any number of collectors can subscribe to that topic and get messages sent to them when the sensor publishes a new value. So it's a piece of glue in the middle, okay? So it doesn't store any data. It just passes it on, and you can get these to run. It has one called Mosquito, which is quite good, runs on a Raspberry Pi, and there's Python and all kinds of bindings for different MQTT things. And so the idea is that I get my readings from my sensor, I encode them into JSON, and I then push them up the wire as a lump of text, because MQTT doesn't care what the message is, it just passes a bunch of bytes along the wire. Does that make sense? So what happens is that this guy gets himself on the network, publishes to a topic, sends readings, and then the data collector, whatever it is, subscribes to that topic, and he gets kicked every time a thing arrives. And this all happens. It's very easy to use, and I'll show you how this works. I use a thing called PubSub Client, which is a library for the Arduino, but it runs, because the devices I'm using are all Arduino compatible, it'll work with them as well. And it works very well. Any MQTT broker that you like, including the one provided by Azure IoT Hub. So that basically means that you can have this thing feeding straight into Azure IoT. That's what I'm doing, and it works really well. But you can use other brokers as well. Some folk have a Mosquito broker running at home on a Pi or something, and then they hang all their devices around the house off that to allow them to sort of publish and subscribe all over the place and do interesting things. And so, yeah, you can do that. This is me inside my program running in my WeMOS device, in my top hat, or in my little sensor here, and I basically say, okay, I'm going to set the server, which is just basically the address on the internet, and then the port number to use, 883 for open data, and secure sockets 8883. So you just do that, and then you say, okay, if I get a message from you, call that method. This is basically a bit of binding to say, when I get told something by the broker, if someone tells you could tell the hat things, it would ignore you for now, it's not listening. But if you wanted it to, that code could run and make it do something. My robot there, this is my robot. These things are called Hull Pixel Bots, and they are awesome because they're pixel bots from Hull. Okay, and he's blue, which is fine. If I want to, if I go into I want to use, there you go, let's go here. Right, if you can see that, okay, this is a website in the web on Azure, and it contains a little editor. This is a piece, it says begin forever, move 20, turn red, wait half a second, turn blue, wait half a second, move back 20, end. This is a program, okay? If I hit, my goodness, I hope this works. If I hit run the robot, my robot should dance a little jig. Shouldn't you? There you go. So now he's doing his thing. Now that's going down to the robot over MQTT. Wow. And so what's happening is I've got this looks like the plain vanilla sort of template for Azure site because I'm very lazy in terms of writing. I can't write web stuff. I'm rubbish at it, but I can do this. So this is basically pushed down to the robot as a string of text, and then there's a program inside the Arduino running in the robot that interprets that and runs it. So I've got my own little language I can use to make the robot do stuff, and it'll just keep on doing it. It's quite cute. But that's MQTT pushing it back. To get back to my plot, maybe I should stop you because you're kind of distracting. So if I go down here and hit stop the robot, then it'll go through and it'll stop. There you go. So that's quite good. I mean, it's not worth a round of applause, but then again, what is? You know? Thank you. So that's how you would push commands back. So turn my light on kind of stuff. That's how you would do that. On the other hand, if you want to just connect and do stuff, then you push out your device name, your MQTT username, and your password, and that then connects you to the broker, which means they can now send and receive messages. Am I making sense? Mm-hmm. 3 method calls, and you're online, and now you're part of a network, and you can do stuff, which is kind of awesome. And then I then say, okay, fill a buffer full of JSON as a string of text, call the publish method on my client, send it to the data topic on the air quality topic, because you can have subtopics, and bang, that's it. Now my broker then gets that, looks through its list of all the subscribers to that topic, and pushes it out to all of those. Now this is how it works. Okay, that's how it ties together. And if I want to, I can subscribe to incoming topics as well, so that I can get given programs and told what to do and whatnot. Now a packet will be fairly small, no more than 100 or 1 or 200 bytes, I guess it is about maximum. So you're not sending vast amounts of data here, but I'm not getting vast amounts of data from my sensor, so that doesn't really matter. So that's how MQTT works, fundamentally. And the only other thing you have to do is every 9 seconds or so, you have to send a message up to the server to say, hey, I'm still here. And so the way that Arduinos work, you have a loop behavior that runs repeatedly, reading the inputs, checking on them, doing things, and then going round again. And so in your loop, you put the loop method on the MQTT client, and that says, okay, I'll keep kicking you and keeping you awake. So that's how, if I go online and look at my robots, that's how I know that that device is turned on and live. If I turn him off, then after a while he'll drop off because he'll stop sending his messages up there. Okay, so that's MQTT for you. There are some other things. Quality of service. There's basically 3 of these. Level 0, we just send it. It's a datagram. It either gets there or it doesn't. We don't know. Level 1, it'll be delivered at least once. So what happens there is I send it, I don't get an ACK, I send another one. And I keep on doing that until he says shut up. Okay, but the receiver might get 5 now rather than just the 1. Okay. Level 2, of course, is the one where there's a layer which says you're going to get it once and once only. Okay, so that's these in terms of expense of making them work. Then you go up from very simple to a bit more complicated. And the Azure IoT Hub works at level 2, which is quite good. I think that's quite I like that quite a lot.
So at level 2, you'll get a message back saying, yeah,
pretty much, yeah. Because you have to, because otherwise you keep on sending them. Yes, that's right. You can know this one. You can know it's gone. This one you don't care. If you're streaming video or audio, which you probably wouldn't use MQTT for, but stay with me on this, you'd use that guy because you wouldn't care if they get dropped. I mean, for my readings, I don't care if one of them doesn't get through. That doesn't really bother me because I'm sending them every few minutes, so I'll get another one. We're not ready. Things aren't moving too fast. The final thing is, this is probably not that useful, but you can send a last wishes message. So if you do time out, then the broker will send this to say, hey, he's dead. But you might already have figured that out by the fact he's gone very quiet. So it's up to you. You can do that, but you don't have to. It's all part of the fun. So, yeah. PubSub client is what I use. There's a thing called Parho, Ellipse Parho, which is very good for a wide range of platforms, .NET, Python, whatever. So you can make your own client programs that will get messages when things are posted to hubs. Want to make your own broker, then fine, Mosquito's a good one to look at. And this is awesome, and also free, called Node-RED. It's another IBM tool. And basically, it's a plug-and-play website where you can just route messages by just clicking on that one and that one, drawing lines. And you can use that for all kinds of funky stuff. So if you want to route packets between brokers and processes and endpoints and whatnot, this is great for that. And it has plugins for things like graphing and whatnot. It's all driven from the web. It's a Node.js type thing. And it's great fun. So, yeah, those are good worth looking at. And so, right. Let's see how it works on the IoT Hub now, because this is a C# group, isn't it? You've got kind of like, and you like Azure, don't you? Because it's pricey but awesome. But you can get a lot of free stuff on Azure, including IoT Hub with I think it's about 8,000 messages a day or something crackers. So if you want to make a cloud-enabled device, starting with your ESP32 or H266 and spending no money on hosting, then you can fire up spin up a free Azure account and then get going. And I think it's a million function calls a month and about 8,000 or so messages a day. So it's quite doable. And so take a look at that. It's good. So they have a thing called Azure IoT Hub, which, well, it's proper. That's what I like about it. Because, like I said, security and management are the two big issues that you hit quite. If you scan and scale up, 3 or 4 top hats is easy. But a whole estate worth of sensors or thousands of these guys at customer sites, you have to manage those properly. So Azure IoT Hub does device provisioning, device simulation. It also has access tokens that have a lifetime and are properly secure. It runs over HTTPS, so eavesdropping is not a problem. And so it's actually a really nice way to do this stuff. It's a really nice way to actually build things out. As far as you're concerned, you tell your WeBoss or whatever it is device to use a secure sockets connection, and then you just use the particular addresses on the IoT Hub. And so what happens is that you go publish, and then you go service bus everything else. So you can do what you like with whatever comes in there. You can actually send things. I'm missing an arrow because this thing can send messages back to the sensors. That's how my robot works. When I hit my send to robot button, it actually makes a connection across IoT Hub down the MQTT stack into there to tell it what to do. That's how it flies. But it's proper. I really like it because it is. You could ship that to a customer, and you could be quite happy that it's not going to get hacked or messed around with. It's really nice. I like it a lot. So there you go. This is how it differs a bit. You have to be very careful because we've seen these before, but the meaning of the various elements is a bit different for IoT Hub. The server is the server address, that's fine. The port, that's fine too. This guy here is the name of the device. The user is a unique username for that device. Now with insecure MQTT, you have the same username and password. That's a bit scary. That's a lot scary. This guy, no. And the password is a great big SAS key, which has got a lifetime, all kinds of good stuff, and that goes in there. So if you put that in, then away you go, and now you're on Azure IoT Hub, and it just works. I mentioned Device Explorer. Let's fire it up. Nothing like firing up like, oh, this is, hello. Oh, this is, right, so if I go Device Explorer. This is a one-stop shop for managing. This is, if I go and have a look in here, then it should show me all my devices, and these are all my robots. And I can, if I have a look at Crystal Maisie, where's Crystal Maisie? Blue Crystal, where are we? I'll give all the robots names because the kids like that. And they're in there, and I've provisioned all these by hand. But I wonder if I could, let's see if this will work. This might work. Let's go. Why not? Device. No. Message to device. Okay, let's see if this works. It might work, it might not. Blue Crystal. If I then send the word blue, will the robot go blue? Probably not. Ah! See? Now, that's just... That's just a program you can get the source code from. It's all open source, so you can build this out. But it has... if I want to make a new robot, I go into here and say management, and I say make a new robot, bang, and I can give it the information to get the keys back. Now, because the source code is up there for you to look at, that means you could put that into a program of your own. So you have a production line where this is coming off, where you get a key out of them, you then get it, run a program that does all this and pushes it back into the device, and so you go. So a lot of power and flexibility here, which you can play with. And so that's kind of like a nice tool. Where's my doohickey? Here it is. So yeah, and you can have an API. There's all kinds of good things you can do here. And Visual Studio Code, that's really funky. Down here, using the Azure IoT Hub plugin, these are all my devices and they're live. I've got 2 devices live, those are the green ones, and 3 or 4 turned off. So you can do provisioning from inside your ID. It's great, and you can make new devices and get the keys and drop them in the code and all kinds of good stuff. So play with this, it's awesome. It's really, really good. This is a lovely tool. It's really nice. And so yeah, okay, so everyone okay so far? Right, okay, so now we've got IoT Hub, we've got our sensors. What we need now is we're getting our messages. When this thing has a reading, up into the cloud it goes. We have to have a way of dealing with that, okay? Now, I'm not a web person, as you can already tell, but I'm going to show you how you use an Azure function to catch the data from your sensor and stash it somewhere, okay? How many of you use Azure functions? Oh, that's nice. Hey, aren't they awesome? I love them to bits. Yeah, okay. Okay. Yeah, okay, I'll take that to the bank. But these are great fun to play with. You can have a go for free, why not? And no server, no nothing. Just a piece of code in the cloud that runs when you kick it. And so this is what you do. You make one of these guys and you say, well, okay, trigger me on the IoT Hub. And you can trigger on the timer, you can trigger on HTTP requests, so you can make it from a RESTful lump of data, whatever you like. And when that thing is hit, when that URL is hit, bang, your code runs. And that's it, there's nothing else. It's magic, it's really clever. So all I want to do is get my data and bung it in the cloud somewhere. And I'm not that, a database, yeah, okay, a bit of overkill. I'm going to use an Azure storage table, which is basically just a big bunch of stuff, okay? And these are, we're talking about Poco. Now to me, Poco is a really old 70s or 80s rock band that was kind of like the Eagles, but not quite as good. No, but that's a cultural reference that nobody here will get, so we'll keep on moving forward. It's fine, good. Poco stands for plain old CLR object. So we've got acronyms inside acronyms, it's great, it's what you want, isn't it? So basically, I make a class instance, and I give it to my table and say store that. And the only rule of the game is the class instance has to have a couple of members, one called partition key and one called row key. And partition key is like a broad categorization of the data. And then row key is a unique value for any given partition key. So I said, okay, I've got a sensor called top hat sending data. So my partition key is top hat, name of the device, and the row key is the timestamp on that data. That works for me because that keeps it nice and unique, and it all works quite handily. So you do that, you end up with, this is my JSON. Everyone here okay with JSON? I like JSON's great. I love JSON. So device, this one's called monitor 15F4B61, sending the temperature, the humidity, the pressure, the PM10 particles, PM25 particles, and a timestamp, which is just the number of seconds since sometime. So that's what's coming down from the MQTT. So how do we store it? Well, this is my class. I'm using Newtonsoft JSON to decode it because that's awesome too. And I have some attributes here saying map the device to the partition key, map the timestamp to the row key. These guys have the same name, they're okay. Stupid case problems, little temp goes to big temp, little humidity goes to big humidity, and pressure goes to air press for reasons of, I don't care. Those are good for making coffee as well, that's another story. Cultural references, oh, it's just so good. Right, okay, so that's my class, okay? I want to store you, fine. This is the entire Azure function. Hello. And nothing, that's it. This is the code that runs when that thing makes a new reading. And what it does is, well, it's called data receiver, that's a good name. It's talking to a table called air quality readings because that's where it's stashing things. I have in the config file a mapping of that name to the great big SAS key that gets me into that. That's on the server, so no one can fake that, good-o. And then here I'm saying, okay, if you get any messages on the devices topic, this guy's a wildcard, then that's when you run, okay? I'm linked to the IoT Hub connection string also in my config file. I'm getting sent a message, and I have a log object which I can use to push information back to tell me that my thing has gone. If I do this in slow-mo, here we go. This is my topic. This is my connection string for IoT Hub. This is the incoming message which I'm going to be processing, and this is the log that I can write to. Now, I haven't done that here because it falls off the screen if I put the logging code in. I want to keep it nice and tight, but you can put a line there to say, okay, so what do we do? Well, we get the bytes out of the message, and we say, okay, you're in UTF-8, just 8-bit ASCII, if you're very old. Using a coding type to do that, bang. So this means I've now got a string with my reading into my JSON, fine. Make a nice new empty air quality reading called result. There it is. I then call populate object that says, okay, take everything in this string and whack it in there. Bang, done. And then return it. And through the magic of Azure functions, it all gets pushed into the whatever. And that, folks, is it. There is no more. And that just sits there. I just press the button and it runs, and off it goes. To see it working, I can use the Azure Storage Explorer, which is another free tool I can use to look inside these tables and see what's going on. Now, I haven't written the code that fetches it back and graphs it yet because I'm not very good with the web, and other folk can do it better than me. But okay, so here we go. Do you want to see how this is working?
Yeah.
Hell yes. Okay, so what we do now is I have to do a demo. I love demos. So I'll take my top hat and I'll disconnect him from the battery. There we go. And I'll plug him into my PC. Now this is going to allow me to talk to him as you do. So that's going to wake up and hopefully find the Wi-Fi. Let's see if it finds the Wi-Fi. We should get 3 greens and then we're away. Oh, yeah, we're good. That one means I haven't found the clock, which there isn't one. So okay, so that's now sitting there. If I go into Visual Studio, now there's a really good plugin for Studio called Visual Micro, which you can use to write Arduino code. It's about 30 quid. Buy it. You can use it for free indefinitely, but it's so darn good that you should just give these guys the money because they've worked quite hard to make this as awesome. So I go in here and I go and I can go into the terminal element. I think, let's find out what COM port we're on. We are on COM port 3, which is my hat. Okay, so I hit open here, and that'll really upset it because it'll reset it. So now it's going through its startup sequence, and this is the text is a bit small, and I have no idea how to make it bigger, which I apologise. So here we go. This is my little program saying I found some Wi-Fi, I found Robert's iPhone, I've got an IP address, the console's running, MQTT is starting, my little reading switch is turned off, I haven't got a BME 280 sensor, I'm talking DevKit 1, and I'm getting values from it. Okay, so now that's now, and if I can have a chat with this chap over the serial port, so I can now say status, and he'll tell me what it's like. Come on. Oh no, go. Robert's a fool. What's that? He's confused himself. I'm going to drag you down because that's not what you type. Oh, you know, I really do miss working with an audience. It's such fun. You type the word status in here. It's not like a terminal because it's different. Do that, and it gives you the status. And I can also say to it send. And if I say send, that forces an MQTT publish. Otherwise, it sends I think it's every 6 minutes we've got the convention. Just that's 10 an hour. It seems to work. So I've just said send a message. Okay, so now what we do is we go into Visual Studio. Oh no, we don't do that. Visual Studio, we're already there. Fine. Push you down out of the way. Mother told me there will be days like these. So get that out run the program. Now this is the Azure function code. If I just close that down for a moment, then there's my POCO. There's my IoT thing. There's my log. You just saw it briefly. This is going to fire up the Azure function and make it work. Now, one thing I will say too, which is very important, I am using for this presentation a Surface Go, the cheapest Surface tablet you can get. So we're running Visual Studio, PowerPoint, Storage Explorer, all kinds of stuff, and it just freaking works. It's awesome. So get one of these. They're great. Everything in my world is awesome. So I'm going to say continue bugging. Don't ask again. And now up it comes. This might take a little while. There he is. So this is basically when I'll show you the code. When my function runs, I've added this chap which says, write me a log, which is giving me the bit of text followed by the string that we've been sending. Okay, so if I go on to here, and I think it actually did it for me. If I go back into here, this is my window. If I go back, if I reopen my terminal window now, oh, it'll reset, won't it? Oh, joy. Let's do that anyway, I don't care. So yeah, it'll reset it. Oh no, we might get away with it. It's all good. So if I now go if I go status, no, I get status back. You want to talk to me or not? No. Maybe it secretly hates me. It's no secret, Rob. Try it again. Okay, we're up. So if I now go send, then it'll send it, and you will see in here we've got a whole bunch of messages come through. I'm trying to sort of get it so I can have both things on the screen at once, but it's really hard to do last time I tried it. So that's my Azure. So if I now go in here and hit send again, you can watch the side jump. There you go, as it comes in. So what you're seeing is, yeah, you can tap if you like, I know. I get paid either way. That said to the hat, send me a message, and then this is the code that, and if you look at the actual dump out, you can see that there's actually, there you go, the you should see, there it is, there's a little piece of JSON with the code that came in from the hat. Now remember, the hat, £4 for the sensor, £2.50 for the IoT connection that's now doing this, okay? So this thing is just, you know, if you want to put...
How much was the hat?
We don't talk about that because my wife may find out. It was a number of pounds that ends in T, which is a lot more than I expected, but it is awesome. Yeah, that was the most expensive. You don't have to use that hat. You can. Other hats are available, yeah, it was quite a lot of money. Yeah, moving on quickly. So if we go into Storage Explorer here, have a look, and I do a refresh, which might take a little while, and if I do a timestamp 0328, that's this morning. If I do a sort on timestamp and then flip it the other way again, boom. Now we should find, there you go, 16, 19. It doesn't sort very well for some reason. I want to try and, but it should be showing the numbers that have arrived because you've seen them go past.
Yeah, there is.
Yeah, there you go, 2016. These are the ones I've just sent. So that was, if you look carefully, you can see these guys here, quite high numbers on the PM25s, but like this sensors all over the place. That was a big one, 50 and all kinds of other numbers. So if you like, I'll scrunch some paper a bit, the numbers go bigger and we can watch them go past, but I'm convinced, I don't know about you guys, but I'm convinced by this. So, but the point I want to make is that I've now got this information in a place where I can do properly useful things. I can pull that back down and search through it or whatever I like. And the effort and the cost is surprisingly small. So the demo worked okay, which I'm kind of pleased about, because you're never quite sure about these things. So moving on. Yeah, that's my top hat. There it is, and it worked. So that's all fine. Let's just take a slight deviation onto how many of time? What time? Another 10 minutes? Yeah, fine. Okay, no one cares. Right, good. So Lora and Azure. Now, how many folk here know what Lora is? Ooh, excellent. Tell Lora I love her and all that. Lora, you should know about because it's another very interesting tech. Low-powered radio with long range. That's what Lora really stands for. And designed for use for battery-powered devices. That's fine. But I mean battery-powered devices with battery lives measured in years. So the idea is you put this thing in the middle of a field and it stays there for a year, sending values or tracking stuff or whatever. So we're talking about very low-power stuff. It uses what's called spread spectrum technology. I don't understand it, but apparently it works. Regard it as a very small SMS message which you can make a device send. Okay. Now you can buy the chips that do this for about £5 a pop. That'll give you a Lora interface chip. If you get this chap here has been pushing values onto Lora since I powered him up. Now whether there's a device in Leeds that can receive it, I don't know. We'll talk about that in a minute or two. But the Lora devices basically send tiny messages every now and then. So you don't stream. I'm streaming video over Lora. You're a fool. And getting 1 frame a week. So there you go. Good news. You can send it 15 to 20 kilometres. Better. It depends on the conditions. You can only get about 1.5 miles quite easily. 868 megahertz is the European waveband to use. Do not do as others, yeah, like I did. Don't go online in AliExpress and buy a bunch of 433 megahertz devices, because although they work fine, they're not strictly legal, I suppose. I mean, the issue is that 433 megs is where you find, this is where your key remote for your car runs on 433. So you get lots of interference and bits and pieces, so not much of a win, but the protocol is the same. No need for a license, but if you start shipping product, use properly certified devices, otherwise you get into trouble. So keep all those things in mind as you go forward. If you want to, you can buy a couple of Lora devices and use them for point-to-point comms. Think of it as Bluetooth BLE with a really long range. You'll be fine. You can just buy. You can buy these little these little Heltec devices, and you can use. Say you have a marrow in your greenhouse, which is just at the end of the road in your allotment, and you wish to track the temperature of that marrow overnight and push the signals, but it's beyond Wi-Fi range. Then Lora would do that for you. It's point to point. It's also broadcast, which means that your marrow growing competitor in the house next door, he can see your messages as well and see what temperature you're running at, and so you do have to be aware of that. And so you can use it for a point to point comms, and if you have a need for that for low data rate messages, then that's absolutely fine. But I want to talk about Lora WAN, because that's what you should really be doing and using it for, and that's where it becomes, from an IoT perspective, very, very interesting, because this is making a big wide area network, countrywide, Europe-wide. In fact, if I take this guy into Amsterdam, I get a much better chance of finding a signal and sending messages, because the network it's using is over in Europe and all over the place. Zurich's quite good too, apparently. So it's a Europe-wide standard, and we're looking at Lora WAN wide area networks, very good for cow tracking. So let's track some cows. Why would you not? Okay, so I've only got one picture of a cow. So in my universe, all cows look the same. So I've got two cows. Okay, their names aren't important. That one's Bessie and that one's Kevin, but why they call it Kevin, I don't know. Moving on. These are endpoints. We fit these guys with a Lora transmitter and a GPS receiver. Say, okay. So every now and then, the thing will send a message to a device called a Lora gateway. You have to buy these things and provision them over the area you're covering. Like I said, 1 every 2 or 3 miles should be fine. So this guy has a network, a receiver, which is tuned to the 868 megahertz bands, and is listening for messages from my cow trackers. And when it gets a message, it takes that and pushes it down a network connection, which could be GPRS, or it could be wired, or it could be Wi-Fi, to the Lora server. And the server will get the messages from all the endpoints out there, and it'll effectively timestamp them. It'll also sort of package them up, and then it'll pass them on to your back-end server that can do whatever you like. So the idea is that you go out into your field and you put a bunch of Lora gateways out there, and you configure them to talk to a particular Lora server, and your endpoints then push messages to the gateway. And if you have a second gateway in top field, to use a farming term, top field, maybe not, maybe I don't know, then what happens now is this cow is received by both gateways, so your back-end server will see which 2 gateways saw it. So you could probably do some triangulation to figure out without the GPS, but that's not guaranteed to work. But the idea is that you've got this infrastructure here, which is tracking your assets on the basis of these little devices that you strap onto them, and then they go off and then wander out and do what they like. So yeah, the gateway. These things, you can buy a gateway for a couple of £100. You can buy a card for a Raspberry Pi that goes on top, a hat which does it. The cheapest one's about £120 for a Pi one. And you have to provision those to get yourself into the game, really. Now, in Hull, we're trying really hard to get the council to do that. But we've talked to, there's Connexon and KC in Hull, are 2 local telco companies, and they're running their own Lora gateways as well. and they'll sell you a service for a certain number of pounds a year per node. So my trajectory is to use, I think, all the things network, which more in a second, to practice it on the free one, and then move on to the proper one later for a public provision thing. So you put these things around the place, and we're working on this at the moment, and you then wire up to the thing called the things network. Now this is community powered, free to use, and worldwide. And these guys will sell you hardware. They'll also sell you gateways and nodes, and they also provide a back end that you can connect to. So what you do is you effectively buy a gateway of your own, and I've done this. I've got a little cheap one, put it in the house and put it onto the things network, and now anybody in my area can use that to send messages which are part of their Lora application. So it's basically, it's a bit like the internet was in the good old days when everyone was sort of free for everyone else to use. And so the idea is that you buy your gateway, put it on the things network, and then any Lora endpoint can talk to it. And in terms of how you go, so this is Hull. We've got a few in Hull, not that many in Leeds when I looked. There might be more now, but you should think about it. You should get one or two of these. They're quite fun. So yeah, the server is the backend which the things network will host for you. And effectively what you do is, the way these things are organized, more in the next slide I think. Yeah. Every endpoint is linked with a particular application. Now one thing which I'll say as well, which is important, all these slides will be on robmiles.com tomorrow, first thing. I'll put them up. So don't worry about writing stuff down. I'll put it all up, and it's all in on the video and whatnot as well. So yeah. What you do is you make a particular application which a particular endpoint is part of. So Rob's cow tracker app is one thing. Rob's flood level warning system is another application, and those endpoints will be linked to that one. And for each application, you have an encryption key. So the node encrypts it with that and pushes it up into the cloud. And so eavesdroppers can see it go past, but they won't know what it means. The gateway gets that. There's an application ID as well, which the gateway then goes, oh, that's part of Rob's cow tracker, pulls off the data, makes it into a packet, and stashes it on the back end. That's how this works, okay? So it's pretty secure. And the other thing which is interesting, when you make a node, there's two ways you can configure your node. You can say, I'm going to burn in the credentials so every single device has its own authentication, or I can do it over the air, where the device wakes up and goes, hello, I'm in this application, is that okay? And they get a key sent back by the server, and off they go. That's good if you've got thousands to put out there in the field, if you want to keep an eye on them and whatnot. So, and here's a little this is a Lora device talking. This is from this device here, in fact. He's sending, now Lora messages, very small. So I'm actually sending 1, 2, 3, 4, 5, 6 bytes, which are the degrees Celsius, humidity, millibars, PM10 and PM25. Now, I've severely scrunched them using a little bit of shifting and bit twiddling, which is fine. But I can put an algorithm into the server end to unpack those and regard them as lumps of data. I can then push these into a local data store, or send them as an MQTT message, or push them out as an HTTP web request with that data in there for my back end to deal with. So this comes into the server, and there's a bunch of metadata with it as well. This is very small, so it's so hard to see, but that's the actual payload data. And then inside here we've got things like which gateway picked it up, and the signal strength and the spread factor and whatnot of the signal as well. So you try and figure out how far it is from the gateway. That might work. So you get all this stuff you can play with. That's the total payload, and in there is my 6 bytes of magic along with the application key and the network type and whatnot, and all kinds of other bits and pieces. So away we go with that. Now, on the things network, you can push the back end incoming messages where you like. A thing called KE, which is very good for instrumentation. We've also got a data store which stores things for a week. You can use MQTT, if this then that, to actually catch your packets and do something with them. If you use this thing, use Swagger. Swagger is really good as a self-describing sort of thing you can hit against them, and so it's all pushed out by, you can make a UI, so an API using Swagger to basically pull things back from there. So you can do all that. This is the one I'm using, it's storage, and this is my Swagger. That's my little web request, and then There you go. Back it comes as a little chunk of JSON which I can then do things with, which is kind of funky. So you do what you like at that point. I don't really mind how you use them, but the bottom line for me is you have this thing which uses very low power, no credentials, no SIM cards, no messing around, no Wi-Fi range rumbles, none of that. This thing just works. And there's one other thing I'll mention, which is that, generally speaking, this is worth saying, you can't send a message to your node because to save power, it won't be listening. A node only listens for a few seconds after it's transmitted. So every day my cow will say, I am in top field, and for a second it will listen for me to send a thing back to the cow to tell it what to do. So your server gets the incoming packet, goes okie dokie, and then pushes the message straight back. And to do that, you can get battery life lasting years. That's how you do it. To level class B, it listens for a brief interval scheduled times. So that means that you can catch it when it's going past. And class C means you have to have a mains power because it listens all the time. So you configure this on the node and away you go. There's a company, I can't recall the name, they put some Lora devices on satellites across the sky. Hello. And for a brief few seconds you can send things to them as they zoom past, which is quite interesting. So the data rate's really crummy, but you don't care because once your gateway's out there, it's costing you nothing to send it, and the distances are quite interesting. So that's how it works. In terms of how you use it with IoT, there are MQTT binding to Azure functions you can use, which will effectively allow you, because the thing about IoT Hub is it'll work as a broker, but it can't subscribe to other things. So you have to have an extra piece of glue, which is what this does. But because you can also use web requests, you could have a function for one of those, or use a timed one that goes on and pulls down batches of data from Swagger every now and then. There's all kinds of ways you can do it to get it into Azure. That's where we need to go. So that's good. All my stuff's on GitHub, including the 3D printable files and the cases for the devices. The cases are another story. That's the case for this box here. That was produced by a Python program that I wrote running inside FreeCAD because I'm insane. I can't use CAD tools. It took me about a month to figure out that in a CAD tool, Z comes out of the floor. Well, if you're writing video games, Z comes towards your face. And so if you've got the wrong mindset, no, can't get, and it took me a while. But so I wrote some Python code that does this, which is quite cute. It's all on GitHub. I'm on GitHub as Crazy Rob Miles for reasons that are kind of embarrassing and we'll talk about forwards. Final thing I'll mention is Connected Humber. If you happen to live in Hull, which of course no one in Leeds does because you're in Leeds. We meet first and Thursday of each month. We have a get-together site, and that's our website. And this is where we're at the moment. I can probably try and show you some live data. We're not using Azure for the back end, which grieves me a bit, but I didn't write the code, so it's all good really. Am I looking? Have I got it lying around? I haven't. Okay, so I'll just open up a website here. So if I just type AQ, there you go. Bang. Then there's a little bit of pollution up. Things are getting a little bit warm over in Cottingham. And so we're getting reasonable coverage. The colour blobs are fairly notional in terms of range. And one of these sensors is actually a sensor which is this guy here. We're pulling in data from the council run sensor. And if I click on one of these chaps, then you should see, there you go, that's what he's seeing. This is the proper one. This is the and so he's bumbling on around 20. If I go into one of these chaps, this is the friend just down the road from my house. This is Robin's stuff. And yet that's getting quite high. And so there's been a big dip there and we don't know why. So if we just look at another sensor that he's got there, is that showing the same? No, it's not quite the same. That's humidity. I want wrong one. Try that again. Yeah, so there was a dip there on that one as well. So what we're trying to convince ourselves is whether or not a sensor that you pay 15 quid for will outperform or is in any way compatible with one that costs several £1,000s. We're kind of getting there. And what we have seen is we've actually seen waves of pollution coming in, where this guy goes high, 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 and we can actually we can track stuff coming in, and we find that really interesting. Windy days, no problem. If it's windy, no pollution at all. If the wind drops and you get still, calm days, ooh, that's where these numbers go all over the place. And what we found is that, yeah, they track over the area, and we can actually track things travelling across. Now, we're putting all this data out there. We've no idea what it all means because we've no idea. That's why we're doing it. That's why we're building all this stuff, just for the sheer, for the hell of it. So if I go back to my presentation, which is that guy, and then pick this guy up. Yeah, so you should build these things because they're easy to do and they're dirt cheap. If you want to go industrial strength, IoT Hub is grand for that. Azure Functions can pull things in. Table storage is the cheapest way of holding large amounts, and that can become a database, I think, if you want, if you need to. Lora is good for long-range networking, moving small data packets, and the things network is the back end that makes the wide area bit work. And MQTT and Azure can be grouped together, and that's robmiles.com, which is where I am, and that's where I play at the moment. And that is pretty much me. So thank you.
Two questions.
Yeah, questions, absolutely, yeah.
You probably answered this in the last section, but have you had any revelations since you've been doing it?
Well, there was a time when it was supposed to get bad and we tracked it being bad. The thing that we're trying really hard to figure out is, does that equality come from Hull, or from Scunthorpe, or from Dusseldorf, or from wherever? And the thing we're finding, I think, is that the background radiation does go up and down. And then if someone lights a coal fire near your sensor, it goes nuts. So we're getting to the point where we're a little bit more confident about what we're doing. We've reached the point where we have sensor designs we want to test with real people. So we've got folks in Hull that are buying the bits, we're making them a sensor and slapping it on their house somewhere to actually get the data in. But it's still very early days. But the one thing I think we can say is that these £15 sensors do actually deliver in terms of the numbers we get. And that was kind of like a nice thing. The very cheap ones are a bit unstable, although they do track a little bit. But the £15 ones, Plantronics and the SDS one, that seems pretty good. So I'd like to get schools building them. I'd like to get one outside the school gate, just doing stuff. But all we're doing at the moment, all we can say about it is it's very interesting. And the data does look like it'll have some worth. But the thing that has surprised us really is that it looks like big chunks of the problem are not stuff that we make at home so much. Although we have seen massive spikes every now and then. I mean, there's all kinds of fun you could have to do with things like when the level crossing barriers going in, you know, Cottingham level crossing, you could be stood sat there for ages waiting for the thing to go back up again. If your car engine's running, then that means around that area for a little while it'll get really bad. So I want to get some sensors on there just to see what effect that does have and how far it goes and how long it persists. So there's lots of fun to be had, but we wanted to get ourselves into a place where the council will take us seriously, and they are doing now, because the council's leads is the same. You've got an open data initiative running in your public offices and whatnot, and Hull want to do this too, and so they're thinking. I think their line is really going to use us and our AirQ data as an exemplar of how to actually merge community and council produced data and visualization. So they'll be making some standards which we can hopefully hook into, so we can use their mapping services and their data to overlay on what we've got, and they're doing fun things with traffic patterns and traffic tracing, which we could then lay our data on top of. So there's lots of fun being had, but there haven't been any eureka moments, because one thing that worries me a lot is if this thing starts producing big numbers and people start going nuts, then that's kind of like a worry, because you've got to be very careful about context.
Influence property prices and
it could do. Well, it's all kinds of scary, and we are just a bunch of. We haven't got any axe to grind. We just think it's better to do this than not to do it. And we are really learning a ton about how you make and deploy an embedded device in the field. And that'll mean that when we want to do the next thing, that bit will, those sharks will have had to go out already, because that bit is quite tricky. But the thing for me that I think, the revelation for me is that, my God, this works. In that we had a guy in Hessel going, it's just gone up, and then the guy in Cottingham a bit further across, it's gone up there, and it goes out towards Head, and then that one goes up. So you can, I think the revelation is that I'm fairly happy now that we are actually doing things which are useful. That's the best you can hope for, really.
My second question. With that hat, if I'm going on a road trip with my family,
Yeah.
and everyone's wearing that hat, can I detect who's farted in the car?
There's a tool called a match for that. It doesn't detect methane. We've looked at other sensors. The NO2 sensors are doable, but they heat up. They require tons of power. I mean, power's a big problem, because if you're running a fan or a heated resistor, then it's really hard to do that. And there are organic chemical sensors, but they're very hard to calibrate, and they drift, they go off real quick as they wear out. So yeah, farts are really hard to spot, but the human being was fitted with the smelted delted principle is the one I would tend to go with, I think, initially. That's a sign. Yeah.
I just got a quick question. In terms of the MQTT protocol that you're using to send the message across with the Azure IoT, is there any other messaging protocols that you can use or send those messages? Or is it just MQTT that you sort of stuck with?
You can use what you like. I mean, I could have done it all with web requests. I could have made RESTful calls into a server to deliver my numbers. It's just that MQTT seems to be quite nice, and I haven't played with it before, so I had to go with that. But no, what you have in the Wemos is a device which is basically, it talks sockets, either secure or otherwise. So anything you like at the back end which understands that kind of stuff will work. So datagrams, TCP, UDP, whatever you like will just go. So you can, and I like the MQTT because it's very dynamic. If I want to see what's happening on one of these sensors, I can subscribe to that one and watch it go past. If I want to have a little light in my study which goes red when the quality is bad in my area, I could just bind that to the MQTT feed from the device that's in my area and see it go. So it's a nice framework. It's a nice pattern, if you like, to make this thing work. But oh no, you don't have to use it. It's just that I found this code and thought, oh well, I'll have me some of that. That looks easy to do. But you could do it tons of other ways. It's limited only by your imagination, really.
Just on from that is, so when you configure it, say we bought one of these Wi-Fi chips that you add to your Arduino and then you connect it to the IoT, do you have to sort of use the USB stick to do that, or does the IoT Wi-Fi chip give off a signal that you connect the SSH onto or connect to? Or?
Okay, this device, which is this one? I've got two. This is my other little portable device, which I made, and this is quite pleasing because it has coloured lights on it, which I like coloured lights. And this might be the right one, it might not. What have we got in here? Yeah, this is the right one. If I turn him off, if I turn him on this way up, how does it work? Turn him on this way up, then he goes blue, start looking for Wi-Fi, which you won't find. If I turn it upside down and turn him on, stay with me, this is good, wink, then he goes purple and two greens. Now if I go online, if this works, I'll be gobsmacked. That's not really a good, if this works it'd be awesome. If I go in here and look for Wi-Fi, monitor Q, that one gets. So if I hit connect on that, then might not work. But this is pushing out an access point which I can connect to, and it isn't going to work, I don't think, because the universe hates me. Why are you not working? Why are you not working? You should work. But the answer to your question is no. If you want to configure it over the air, you can do that.
And then you go into IoT Hub and then find that device to you on
You can. I'll turn that off because it's going nowhere. But you did see the host. Oh, it's there. Okay. So now if I go 192.16, 8.4.1 and don't bother with the Twitter bit. If this works, then it will be worth a round of applause, because I don't think it will. Ha! Oh. Don't go looking for Twitter, it ain't there anymore. HTTP. Oh, okay. Ah! Alright, so that's really upsetting. Okay. Okay, oh my god, it's worked! So this is a web page being served out to my air quality sensor. We've got 3 lights, so two lights now, so it is happy. So if I go in here, I can say, okay, boink, and that's the access point name, that's the Wi-Fi password, MQTT password, position of the thing on the earth, and then is it indoors or outdoors. So I can type it into the waveform and hit save, and it'll save them in the device. If I go back to the other ones, then here I've got full SSID for a bunch of different devices. I've also got hardware pins and configuration stuff I can set up. So if you want to, you can configure this guy completely from a web page. I've got this version. You can push in MQTT messages over the serial port to do the same. This chap, you can talk to over the serial port as well. You've seen that too. But you don't have to actually burn the stuff in. You can do it in other ways. So you could have this thing wake up as an access point and go online and fiddle. This is how Alexa's configured. Alexa is just the same thing, but it hides it behind a rather clever piece of JavaScript in your web page, which disconnects the Wi-Fi and then reconnects it without you spotting it, which is quite cute. This is how they all work. But I'm actually quite impressed that worked. That's rather good. It's also blown me off the local network, rather sadly. So everything will now start falling apart in front of me. But if I turn him on that way up, then he wakes up and just goes off and finds his access points and does his thing. Yeah, now it's sad now. It's unhappy. So whether I can get back on, I'll go to Web's iPhone. Why not? I know that works. And so yeah, he's just now trying to find Wi-Fi and getting. This is quite fun. You can sit and watch that for hours. But he's every 5 seconds he's trying to find the Wi-Fi and failing. So he's going to keep pausing. Yeah, there you go. So yeah, bottom line is just you can make that thing into an access point or a client or whatever. You can put a website. It'll do MDNS, so you can use Bonjour to discover its name rather than the number I had to type in. It's just play with it. It's stupidly fun. It is, and it's £2.50 is the cost of entry. Crazy.
That's dangerous.
It is very dangerous. Yeah.
How well do the air quality sensors work if they're moving? Because I'm sort of thinking, like, I cycle to work, I'm going past lots of trucks. Could you have your own sort of personal box of how dirty your own areas?
You can. We're working on that because the sensor itself pumps out readings about every half second. But if you have a piece of pipe on the end, that might introduce latency. And we're not sure. But there's a couple of very keen cyclists in the group that want to actually put this in a backpack and then just go down the street and see what numbers they get. And we have to then fiddle with how our mapping thing works, because a moving sensor has to be displayed differently from a stationary one. And that's a little battle we'll have to try and sort out. But it's certainly something which is worth trying, although I don't have the hard and fast answers for that.
Is it onto the helmet rather than?
Well, again, we're doing research now. I don't know.
You don't want to interfere with your helmet for falling.
I mean, there's a thing you can buy for about 150 quid, which purports to do this, which you can strap on. It's that little device with it. And I want to try and find out more about it because I want to know how it works. But I don't really know. I have no idea. But wouldn't it be fun to try and find out?
Yeah. You strap it on a drone and all.
You could.
Fly across.
We thought about drones. We don't know whether the air down here is worse than the air up there. And we don't really know whether you can measure that. I don't know. It's just a great thing to fiddle with, and at the same time we're learning how to build a whole raft of services. Great fun. Yeah.
What's the relative power consumption of air sensors versus other kinds of sensors, like cameras?
Okay, this guy, when he's running, takes around 200 milliamps or so. But we've designed a circuit board, which I haven't brought with me, unfortunately, but it's I know where it is. It's on my blog, but also, we have a GPIO control switch to turn the thing on and off. So our plan is every 6 minutes you turn the power on, wait 30 seconds, take a reading, and shut it down, which does two nice things. It reduces the power consumption and it makes the sensor last longer. And so that's what we're playing at. But yeah, the Plantronics sensor, this little blue one here, you can do that in software. Send it a command that says shut up, and it shuts down, and you can send another one to wake it up. And in the shut down state, it's taking microamps, it's taking very, very small amounts of current. But we have discovered that, yeah, it's difficult. Power consumption is a big problem. It is. I mean, I've been playing with garden lights, because you can buy a garden light for about £4 with a single AA battery, nickel metal hydride, and the solar cell to power the light. And we've got some inverters that step that up from 1.2 volts to about 5, and then you can power the whole thing. But the current you take is quite nasty if you try and do that kind of thing, and we're not sure how long it'll last. But it doesn't cost you much to start playing with it, and you never know, you might make it work. It's just the other thing which is amazing is that printed circuit boards, 50p each. PCB about yay big. How they're made in China, 50 pence. Do your business cards as PCBs. One of our members is now doing them. And so yeah, don't bother buying mats for your coasters for your drinks. Just get a whole bunch of PCBs made. Why not? It's just crackers. The stuff that you can get made. I mean, the level from that is buying the PCBs and having them populated, which I haven't got to yet. But yeah, this is so much fun to be messing around with this stuff. Yeah.
Question. I don't know if you mentioned if you were measuring other things, but are you measuring temperature and pressure as
It's a
well?
really good question. I forgot all about that. There's a particular device we quite like called the BME 280, which is made by Siemens. It costs about £4, and that will give you air pressure, air temperature, and humidity. And so yes, you should see those readings popping up. This guy has got one of those in, so he does that. We're wondering whether or not we can actually use local weather data for those values, but we're also wondering how hot something in a box gets. So we're thinking about putting sensors in there anyway, just so we can make sure that the box isn't heating up in the sunshine. Because making a box you can put on the wall all through the year and not have it destroyed by the temperature or rain or. It's a lovely story. One of our chaps had 2 sensors, and one of them just seemed to break. He went down to nothing. He was very concerned because it meant that they weren't compatible, they weren't tracking. He went and had a proper look, and a spider had laid some eggs in the inlet tube and blocked it. And that was that. No air, no readings. And so you have to be very careful about your water ingress and insects and whatnot. And that's completely outside our comfort zone. So we're building things and playing with them, getting things laser cut and trying to. You guys have a makerspace in Leeds, don't you? Yeah. So you can get things laser cut and build bits and bobs as well. You should definitely do that. It's great fun. But yeah, we are getting those in, but we're not sure whether you need them or not. We think for things like schools, STEM type stuff, it would be kind of nice for them to have that data to play with.
So I was just wondering, and this is not an original thought, because my father was an oceanographer, and he used to throw things off ships to track the movements of the ocean with the temperature and pressure and salinity. You have a marker, which is the pollution level, and you have the pressure and the temperature. So you could be using them to actually track the air patterns. Maybe.
We are wondering how much of a factor wind is. So wind speed is something from direction, might be a thing we're going to be looking at. But we haven't had a cheap sensor for that yet. And so, I mean, there's about 15 of us in Hull actually active in this, I would say. And so we haven't got a huge amount of people doing that. We'd love to have more members doing stuff. And we'd love it if people like you guys or whatnot started doing things and we started sort of lobbing it all to GitHub or somewhere and going further. Because you go around the corner and find lots more corners. Which is fine, because whatever you're doing, you're learning stuff.
All right. Thank you very much.
Twitter, robmiles.com,
Yeah,
excellent
good point.
blog, loads of resources in there. Crazy Rob Miles on GitHub. Go and volunteer on his community
Yeah,
project.
come to
do some
Hull every
websites
month.
for him.
Yeah, that's me.
The lovely people from Fruition pay for beer down the pub. We'll be going to the pub here in the road, which is the Brewery Tap.
Yes.
Brewery Tap. Right now, if you'd like to join us, you're welcome.
Thank you.